This is mine too.
Oh, good. You have your name on it. They're good. No, yeah, sure. All right, guys, so I want to tell you, I promise to catch up. I lost a lot of grading time this weekend, and normally the weekend's the only time I have to grade. So I'm definitely behind on grading. So I promise I'll catch up now that I'm feeling better. Of course, this weekend I have a conference to go to, so we'll see how much time I actually have. Are there any questions from homework stuff? Yeah.
3.3, numbers 6 and 18.
All right, cool. Now, while grading the homework, this is a very strong suggestion. A lot of the problems that people have solving equations is because you don't show yourself what's still there, what's happening. You sort of do bits and pieces and then try to collect them. And that's when things kind of like suddenly come to the other side of an equation. You can't just suddenly have it go. So I'll have a problem like this. And suddenly somebody writes 11x minus 1. Now, what did that person do? Can you guys see what that person did? Where did they get 11x from? But what's wrong with doing that?
You can't combine them with the equal sign still there.
Yeah, so it's okay to say you're supposed to do this, but really get at why this is wrong. I mean, that's really what irks people. Like, well, why is that wrong? 5 and 6 is 11, leave me alone. Are they together?
No.
No. They're on opposite sides of the equation, so how could they possibly be combined if they're not even together yet? Cool. So it's sort of like if I had 5 equals 2 plus 3. That's true. Right? You can't suddenly have this 2 come over, 7 equals what? Or just have 5 equals 2 plus 3 and then just write 10. Because you just added them all again. 10. What? What is it? Are you guys semi with me? So if you start with an equal sign, you better have an equal sign all the way through. They can't suddenly decide, nah, I'm done with this problem. I don't want to be in the first place, the little equal sign says. It's got to be the whole way. So let me actually do your specific problem. Number 6. Okay. This is definitely a kind of problem that's going to give some people some trouble for a couple reasons. Number one, if you're not really comfortable with equations, you don't like it when there's stuff all over the damn place here, right? Can somebody kind of point out what's wrong with this in relation to what our goal is? What's our goal? Where do we want to end up? Yeah. M equals something. Cool. That's what's always driving us when we're solving equations. We're trying to pick away at all the stuff, the reasons why M is not by itself on a single side. Yeah.
Well, the problem I had is the 4's cancel each other, and then you just have 2 M's. And
I love it.
Yeah.
And this is why it shouldn't be a problem. Because the very first thing you can try to do, the numbers are not together, right? So how do you, for example, how do you kill this 4 here? Subtract the 4. And what is 4 minus 4? So you just have a negative 7m there. And over there, you have a negative 3m and 4 minus 4. Go. And right here, some people will just stop and go, and I understand. They go, what? There still is a number there. It's 0. It just doesn't show up. So you still keep going. You got your numbers together. They happen to kill each other entirely. Well, that's their problem, right? Now you still need to get your m's together.
So you just divide.
Careful.
Add 3.
Good. Well, yeah. So you could either go one way or the other. So I could add 3m. You guys with?
M equals 4.
Yeah. I'll show you a little simpler problem than this that has the same kind of problem, so you can really see why we do what we do. But let's finish this one out. Negative 7 plus 3, minus 4. Negative 3m plus 3m.
Zero.
And very often, that's when I get that, and somebody circles this.
Nothing.
Somebody circles this.
Yeah, that's
The
it.
problem is, that side is 0. Poor little 0 dude. I know he gives us a lot of trouble, but he is a number. He deserves to be there. Right? So this equals is still here. It can't go away. Negative 3m and 3m is 0. And then people now, on this step, people will get confused because they'll let the 0 bother them. Yeah.
M equals 0 divided by negative 4.
Beautiful. So, very often we'll let this side tell me what to do. It's not that side. I don't care what the hell's on that side. Why is m not by itself? That's what tells me what to do. Why is m not by itself? What's with the m? Negative 4. And what's the operation right now? Multiplication. So how am I going to kill that? Divide by what I don't want. So what's 0 divided by anything? 0. Cool. So let me show you a more specific example of what I was talking about in the middle. If I had, watch how you're not going to have any trouble with this problem at all, is my prediction. Let's see. There's no tricks here. Don't freak out. Whatever you think is probably right. There's one step to solving this problem. What is it?
M equals.
Tell me the step you took. Yeah. The m's are not together. The numbers are all together. But the m's are still on both sides. So you want to kill him. Why do you want to kill him specifically? Why don't you subtract 2m?
Because you want to get one.
Because the m's want their own side. I want to leave these numbers alone. Whatever's with that number, I want to kill it. I know my method of solving equations is very violent. There's a lot of death and killing. But to me, it just makes it more interesting. I was thinking about this really weird, geeky Braveheart. Oh, just shut up. 2m minus m, m, equals 1. Now, I make one little adjustment to that problem. And you do the same damn thing. So instead of a plus 1, I'm going to have a plus 0, which will end up making it look like this. Do you see how that's the only change I made? So why should my next step be different? If I put a 1 there, you subtract the m. If I put a 4 there, you subtract the m. If I put an 8 there, you subtract the m. Right? If I put a 0 there, you still subtract the damn m, don't you? You still don't have your m's together. You don't care. You don't think ahead, but there'll be nothing left. Right? I like that you're trying to be nice to that side. You don't have nothing left. But you have to do it. You know you have to. So subtract the m, and you get, what's 2m's minus an m?
1.
1m equals 0. So there is nothing wrong with having 0 as an answer. There is nothing wrong with that. Okay. In fact, what I want to do with you real quick, I want to let you guys be a little creative. I'll let you guys do something you normally aren't allowed to do. Not allowed to, but you don't even realize you could if you wanted to. And I'll show you an example, and then I want each of you to try to do it and then see if anybody wants to share. All right? I'm going to create an equation knowing the answer ahead of time. So I'll show you what I mean. So very often this is how I'll make problems for the test. And I want this really understood. And real life equations pop up because of the situation I'm in. So a friend of mine is a financial analyst. He used to be at Dell. He's now at this little mattress company. And what he does is he analyzes the market and tries to tell him what the price is at. And the equations tell him. He plugs stuff into the equations and pops out a number that says set your prices here. And they go, okay, and they hope to God it makes money. So the equations come because of what I see. In class, I just want to make equations that I know will come out decent for right now, so we don't get freaked out by weird answers. You with me? So very often I want to start with an answer. Let's say I want the answer to be 7. So far so good? So now I'm just kind of creating an equation just to test you and if you can solve it. In the real world, there aren't people just sitting behind the scenes, let me make this equation, hee hee. No, in the real world, we're doing equations based on the rocket flight, the trajectory, and all the velocities, and the wind hitting it, and there's an equation, and how fast should we be moving the damn thing so it doesn't fall and hit a building and all that kind of stuff. You know, the equations come out of the situation. So really simple equation I could make, for example, one example would be x plus 2 equals what? What did I do to this side? What did I do to this side? Added 2. So what do I better do to that side? So there's a very simple equation whose answer is this. Are you guys with me? Semi with me? So you know the answer to this is 7. You know it. So let's make it a little more difficult. Right? Let me see if you guys are good with this. So what if I do, what if I add an x to both sides? So now that'll be 2x plus 2. What has to be over here? Careful. So if I add an x to both sides, oh, there are 2, you're right. I could put 16 there, I appreciate that. This is really good, and I don't want to confuse the hell out of anybody. I could either write 9 plus x. You with me? Because what did I add to this side? X, so I better add an x to that side. Or I could write, where the hell does 16 come from? Because we know that x is 7. So what's 7 plus 9? 16. So both of these equations have the same answer, don't they? Why? We know the answer is 7. We made these equations based on that being 7. I'm really hoping you guys are starting to go with me a little bit. This is the part of this you guys never get to see, and I always think if you guys can make up your own problems, you can kind of see, okay, everything is just the reverse of what I just did. If you added 2 to undo to kind of hide the 7, you better subtract 2 to see the 7 again. Maybe. So I want you guys, you can do whatever. In fact, another one could be from the bigger, x equals 7. So 2x would equal what? 14, I love it. Right? Or you could do, what's x divided by 7 then? 1. I love it. I mean, you guys see how much freedom you have. And every single one of these equations you create has an answer of 7, of course, because that's where you started. So take a minute. Pick your favorite number. Pick your favorite letter. I don't care. You can use Y, M, W, Russian letters, Greek letters, I don't care. Start off, so if you like the number 3, make like 3 different equations that all have an answer of 3. Just try this out. Be creative. If you get it wrong, it's not going to count against you. So just try and see what you can do. Make a very simple one maybe, and then try to make it a little more complicated. I want to see if anybody's favorite number is 11.7. My favorite number is 9 sevenths. So let me do this. Give me, anybody want to share just an equation? Don't tell me what your number is. And then the rest of us are going to try to figure out what your number is. Yeah.
X divided by 33.
X
Divided by 33.
divided by 33.
By 3 plus x.
Times 3 plus x.
With the 2 like parentheses. Yeah, 3
Minus
Minus 3.
minus 3
Yes.
equals
Yeah, I get it. Like 63?
second.
63, I get it.
Oh, equals 63.
No, I did read it without any, like x equal, no, without any number.
Oh, you didn't start off with a number.
No.
All right. Now let me say a couple things. This is a little bit beyond what we can do yet, because, and that's fine. There's nothing, because you could imagine you could start to write an equation: x minus 7 over x plus 2x cubed equals 11x to the 4. Oh my God, that's an equation. It has answers. What are they? I don't freaking know. That's more like on the level of math 90, math percent. We're not quite. In fact, this would be a math 176 problem possibly, because it's got a lot of higher power things. So there's nothing wrong with what you did. It's just that it's a little too complicated for us right now, because when you multiply this in, you'd have to distribute this. Won't you get an x squared there? And we don't currently know how to solve equations that have squared variables in them. Okay. So we'll put this one as a showcase item. So don't worry, I don't want you to feel bad or anything. That's the whole point of this, is just to be creative. Yeah, you had one and then you had one?
Oh, mine's really simple, not for that.
No, come on, no, it's fine.
It's x plus 3 equals 8.
X plus 3 equals 8. Okay. So then what would you do to solve that? Subtract 3. So what's her number?
5.
X equals 5. Okay, cool. So we know your number. Yeah.
2x plus 6 equals 4x plus 4.
All right. Take a second and try to solve that. I'm trying to figure out her number. Don't want her to have that over you.
I'm sorry, that's 2 is the end, not 4.
Oh, we'll work with this then. I think we're all. It's all right.
-1.
We're going to change your number a little bit.
Okay.
So what do we get here?
Yeah.
What'd you guys do
2x
first?
2x minus 4x.
All right, so you could subtract the 4x.
Yeah.
Then everybody subtract the 2x instead? So people either like to keep their variables always on this side, or they like to keep their variables positive, right? Very often keeping it positive is nice so you don't make a negative mistake later. So let's go ahead and do that. We'll end up with the same answer, so don't worry. We have to. So if I keep my variables positive, I can subtract and move them this way. These go away. 6 equals 2x plus 4. You guys with me? So everything else stays exactly the same. Trust me. A lot of you guys who aren't doing this for yourselves, very often some people work just with a piece of it and then they bring the rest of it later and then they bring the rest of it later. And in the process you've forgotten what was on what side and where things were. Do not do that to yourself.
I don't line it up on that side.
Exactly. What's the next step here?
Just
6 minus 4.
Subtract 4. So you move the numbers this way because I moved my letters the other way. So now I get 6 minus 4.
Plus
2 equals
2x.
2x, and that's gone.
1.
And then divide by 2. Now she's tricky. She didn't tell us the right equation. So her actual number, she said it was supposed to be a 2 there?
Yeah.
All right. So then there would have been a
But that
4
works
there,
too.
so then your number would have been a 2. But the important thing I'm hoping you get out of this is so that it makes a little more sense, hopefully. That's my hope. What you do to solve an equation, if you can see yourself building it up in the first place. When you solve an equation, you're trying to take away all that extra crap that somebody piled in. Right? Double it, add 3 to both sides, add another x. triple that side, do the, you know, you're just trying to clear that all away when you solve an equation. Cool.
But
Yep.
exercise 33, number 1.
Oh, let me get, one more. Anybody else wanna tell me an equation? Anybody got a, everybody else? Yeah.
Well, I don't know. Okay, 2 parentheses x plus 6 equals 3 parentheses x plus 2 plus 2.
Kick ass. Alright. So, just to get you guys started, and we'll let you guys do this, what's the very first thing you're gonna do when you go to solve this?
Distribute.
Distribute. I like it. You're right. So you try to attack this, and you know the first step already. Distribute wherever you can first. There's the first step.
Yeah.
Now what can you do next?
You
Subtract
got,
2 from 3.
what you got is.
2x.
You could.
The
Now,
like
there's,
terms.
I wanna make sure this is understood. There's a lot of things you could do right now, and they wouldn't be wrong. But I'm gonna always do this in the way that will keep you the straightest, that will keep you online the best if you're not that comfortable.
The like
Is there anything I can do on that side
like
still?
term.
No.
By itself, no. Anything I can do on that side still, yes.
Plus 2.
So just to make sure that you keep everything straight, you try to make each side as simplified as possible before you start moving stuff around. Because the people that start to move stuff around are sometimes the ones that forget other things before they put them together. Now, if you subtracted 2x right there already, there's nothing wrong with that. You may be a little more comfortable with solving equations. So, but in general, to keep things by the book, we simplify both sides, so I get 8. And now I can start moving stuff around. So if you like to keep your variables positive, you can subtract 2x. Get the variables together, right? Get your x's together. Kill them from over here so they're gone. And so they effectively show up over there. So now on this side there's only 12. There's only a number there. All the x's are now here. There's 3 minus 2. X. So then the last step is to get the numbers together.
Subtract 8.
The only number that's not together is the 8. Kill it on that side so it shows up over there. How we doing? Cool. So we figured it out. All right. Have you guys ever seen somebody ever had to go through something like that before? I mean, I kind of like doing this every now and then with my students, saying, here's how you create a problem. In the real life, the problem is given to you by real life. In the classroom, we have to kind of make them up to get practice. Okay. Any other specific questions from homework before we keep trucking along? Yeah.
On page 175, equation 3.
Number 3. Section 3.2, number 3. Whoa. That one there, right? Okay. Now again, you have very specific things to go through to solve these equations. Through your math career, equations are going to get harder and harder. You know that. But you always can start, is there anything to distribute? Is there any like terms to get together on both sides? Then you can start moving stuff from one side to the other. You've got a very definite way to attack an equation. So there's obviously nothing to distribute. Is there anything to get together? Yeah.
7 minus 5.
Yeah, so -7
Yeah.
plus 10,
Plus 3.
so it's positive 311. And that side's still the same. Cool. And now we got one last step here, right? Because the m is almost by itself.
Add 5.
Add 5. To kill those -5s, I add 5. And just to make sure this is, how do I check this? Plug it in. So you can, oh, that's really nice. I think I made this point, I don't know if I made it here. In history class, you can't check your essay against something to make sure it's right on a test. Please compare the War of 1812 with it. You can't plug it in somewhere and go, oh yeah, that's right. But in math, I'm trying to make math a little bit less evil. In math, you can at least get an answer and then go freaking check it, see if it actually is the right answer. It's nice. So you plug it in. So I plug in m equal to 8 right there, right? So on this side, of course, I get 3, and on that side, I get 3. Check. Cool. Yeah.
3.3, number 18. P.
Since you said please. So this one's got a step a lot like the one, this is the one you're talking about, right? Of course, what's the very first thing we can do here? Distribute. I like it. 3z plus
Plus 6.
6. This side's the same. Now, do you see how we're going to run into a problem that should not be a problem anymore? Right? Your brain, when you get to this step, your brain kind of knows ahead of time, goes, oh shit, the 6 is going to go away. And then the rest of your mind goes, I don't feel good about this. Right? When you hit a problem like this, I can almost feel it. The student's like, I don't want to do that. But, I mean, it's just going to happen. You try to get your numbers together. So you don't want them there. What are you going to do to kill it?
Subtract.
And it just naturally, it's just nature. You go by the bush, they kill each other. That's it. Right? National Geographic. 3z equals 5z. That's the only survivors. Now, on this step, the biggest mistake on this step is people start to divide. Bless you. I will tell you, you almost always divide once you get all your variables together. I don't have my variables together yet. If I start dividing, I get some really freaky stuff. Trust me. So my variables are not together yet. So just imagine, if there was a +1 there, there would be no problem here, would there? I would know to subtract 5z, there's not a problem. It's just, the minute I take that away, it suddenly is a very difficult problem, but it's the same problem. You still need to get those together, so what do? Yeah, you can subtract, that's fine, either way. So now they're gone here, so what's there? 0. 2z. 2z. And then, of course, the last step, like I just said, the last step is almost always divide. Divide by 2. Don't even worry about it. I don't care what's on that side. What does this side tell me to do? Divide by 2. And then 0 divided by anything? 0. This is a really easy one to check. If z is 0, you get 3 times 2 is 6. You with me? Equals 6. Because 5 times 0 is 0. So when the answer is 0, it's nice to check. You just kind of cover wherever the hell the variable is because it's going to go away. All right, how do we feel so far? Not too bad. So equations are really not that bad, but they're stupid important. They're like almost any problem in any math class you hit eventually boils down to solving an algebraic equation. My Math 281 students, Calculus 3, Very often, the biggest problem is once they do all the weird shit that we don't even know what the hell it might be, they get to an algebraic equation, they forgot how to do it, or they make a little easy mistake. You with me? So this is throughout all of mathematics. That's why it's stupid important to solve an equations. If you can't do this, you're stuck. Yeah.
So far, I've been okay, but is there any reason why you would subtract the number with the variable first? I mean,
Yeah, sure. On this
second,
step,
could
on
you
this
do
step,
that?
I certainly, yeah. So
Okay.
if I was right here on this step, we
But-
could have elected to do this first.
That's what I did, and I've been fine so far, but there's no reason why I should do the number by itself first.
You guys see that? So I could subtract the z's first before I subtract the sixes. It doesn't really matter. As long as I get my numbers on one side, letters on the other, which one do you do first? I don't care. Now the nice thing with this is it's a little bit less freaky, in a way, to get to the step we got here. It's a little less freaky. If you get to this step, it's a little freakier for some reason. That's not that bad. And then you still do the same last step, divide by 2. I like it. So it's almost bad, in a way, that there's so many ways to do these things. Yeah, and then I'll come back up here.
Section 3.2, number 15.
15. Oh, yeah. So page 175. So what do you do first? I love it. Anything that you can simplify, you do that first. So on this side, I could put the negative 26 plus 16. What would that be? Negative 10.
Negative 10.
I know what you meant. Don't worry. You guys with me so far? Not too bad, right?
And then you multiply.
And then you just think to yourself, the same thing. I can't really stress this enough. Later in mathematics, you guys will learn other functions. If you've never seen them before, you can even imagine what they are right now. You can learn all these other functions that do other things besides. We know multiplication, division, addition, subtraction, but there are a lot of other functions beyond that. You'll do the same thing. Whatever the function is, you'll do the opposite of it to keep going, right? So right now I'm doing what with the 5? Dividing it, so what do I have to come in and do to undo it? Multiply. So don't make a big deal out of it. It takes like 3 seconds internal conversation. It's division now, I want to multiply. Okay. Multiply by 5. The 5's here. I know we're not there for fractions yet, but if you want to, that might help people out. Put it over 1. So you can see a little better that those go away. So on this side, what do you have left? X. Negative 50. Cool. Why not?
Also, over,
Yeah.
54 on 3.2.
All right, some of you guys have in your head, just keep asking, we get the whole homework done. All right. At some point I go, no, that's enough. You said what now? I was busy
54.
being silly. 9 minus 14. So this is kind of funny. This is on the whole other page in another section of the homework, but do you see how these are really, as a math teacher, I say, these are the same exact problem. And as a student, very often you say, are you blind? Totally different problems. But I've got my variable divided by something equal a subtraction problem, really. Variable divided by something equal to a subtraction problem. They're the same exact problem. So as a student, you get to kind of break yourself out of the pattern of thinking every single problem is a whole new thing. No. They're just a few basic types of problems. If you can start identifying them, you won't have nearly as much trouble. So what's the very first thing here? Just like there.
Subtract.
Yeah. Simplify that side. Good. Negative 5 because the 14's bigger.
Equals 6.
And then what do you do? Multiply by what you don't want.
Multiply by 5.
I'm dividing by this thing, so I better multiply by that thing. Cool. So on this side it goes away. Negative 5 times negative 12. Positive 60. Good. The negatives go away. Yes, sir.
4.2 over 30.
Cool. Everybody cool with that? Have we gotten to chapter 4 yet? No.
Oh, sorry.
That's all right. We'll get there. Okay.
Do you want from 3.4?
Yeah.
Number.
Remind me, it's been like a week. What exactly did we cover out of 3.4?
We have that.
Okay, good. All right. That's where I thought I left off, but I wasn't sure. All right, so let's do this. Let's go ahead and get back into 3.4. So 3.4 is our first example of solving the equation is the last step. Right? I gotta first do some other stuff to get there. So that's what really happens in a lot of math classes, do all this other stuff, and then I come up with an equation that I can solve. So let me start us off a little nice. Because this whole section is about translation from English to math. And that's why people don't like word problems, is because of the fact that it does take some translation. And I just remembered that I forgot to bring the handout. Damn. So I'll do some really good notes. Okay, so I don't know if this is true for you yet or not, but when I say word problems, does anybody get a feeling in the pit of their...
Oh, yeah.
All right, so I'm going to try to help you get over that a little bit. The first type of word problem I don't really put in this category truly, and I'll show you what I mean. It's like one step away from that. So for example, if I wrote this down, can you guys say this in English and don't say x plus 5, it's English. Can you say it a little bit better? A number,
The number added 5 equals 7.
I like it. Another way you could say it is, a number increased by 5 results in 7. I mean, there's a lot of different ways you could say the same thing. You with me? 7 is the result of adding 5 to some unknown quantity. I mean, there's a lot of different ways to say the same damn thing. You with me? That's what English really is. A lot of ways to say the same damn thing. That's a little kind of just degraded the whole English language. I'm sorry, I didn't do that. But they all boil down to the same idea. So let me start off the other way. That's math to English. Let's start off English to math. So I can say a number decreased by 2 results in 11. So now, this is a very simple problem. You could probably get the number without even doing the algebra. But the reason we have simple problems is so we can get used to the algebra. How do I write this in math?
X plus 2.
Yeah, a number decreased by 2 results in 11. I like it. 11, yeah.
13.
Yeah, and then so you add 2. Get 13. So what I really hope to get to is that the only really hard part of a word problem would be setting the equation up. Solving the equation should not be that big of a deal. Yeah.
We can say x equals 11 plus 2. That's all.
The straight translation from here to here, the straight translation is this. There's no other way to directly translate this. You can start to solve it by doing this, yes. Cool. Here's one that's a little more involved. 8 less than 4 times a number. Is that number Yeah, why not? Sorry. See, I'm not that evil. That's my evil laugh. Remember that less than is the evil one?
Yeah.
So 8 less than 4 times the number, 4x. How are we doing so far? Is that?
Yeah.
Yep. Is, and anytime you see is in there, it almost always will be equals that number. Cool. Now I'm being semi-evil here. I can't remember if any of our equations have ended up in anything that's not a whole number or an integer. The really nice thing about the only time fractions are okay is when they show up at the end and you're done. You don't have to do anything. So don't freak out. I'm trying to warn you, we're going to get a fraction. So how do I solve this? There's a couple different ways, really. So one thing I don't want to do is add 4x. Yeah, I could add 8 and then subtract x. There's nothing wrong. I could subtract 4x because aren't the x's almost all together? But then that would result in negative variables. So if you really don't have it in negative variables, you can add 8. But then what do you still have to do?
Minus that x.
Minus the x. Get the x's together. Okay. So what's that?
3x.
Yeah, good. And then the last step? Divide by 3. Oh, Jeff, we haven't talked about fractions. I don't care. You're done. If you wanted to check it, that's where it might get a little bit more disgusting, right? How you guys doing so far? Is that? So let me see what you guys think about this. Don't say anything out loud. Try to do this, and I'm warning you ahead of time. It's a little more complicated. See if they actually do one like that before I do it. Oh yeah. All right. There we go. I'll do one right. There's definitely a bit of a twist to this one. So don't feel bad if you don't write it down right the first time. Let me show you a couple things you could do. And this is where I start to feel a little too much like an English teacher, because you start to try to break this sentence down into its parts. And it reminds me of, okay, what's the subject and what's the, oh God. What kind of cuts the whole thing in half?
Equal.
Equals, and where is the equal sign? What word?
Middle.
Yeah, I like the middle.
It's gonna go in the
So the
middle.
is, right?
Yeah.
All right, purple, you're done. So right there, that's the equal sign. That's what cuts this thing in half. So this is one side, and then all this is the other side. So this side shouldn't be that bad. 30 decreased by a number.
So is everything minus 6?
Good. Is, now, equal to the product. Now if I say the product of, what do you expect from me after that in general? Tell me what the product of.
Parentheses.
No, let me try and say this again. If I said, what's the product of 7? well, how would you look at me?
Division.
If I said, what's the product of 7?
Oh.
And you're all like, well, what are you doing? You're waiting for the other freaking piece, right?
Yeah.
The product of 7 and what, Jeff? And you're all wondering, did you take your meds this morning? So the product of 3, so the product of 3 and the sum of the number and 6. So that's where people get messed up. They start putting this plus 6 in the wrong place. What am I multiplying on this side? 3 and the sum of the number and 6. Is that cool? Yeah. Kick ass again. You know, you gotta be careful.
I messed up.
Oh, okay, yeah, you had the plus 6 on the outside, exactly.
I got 30 minus x in reverse because the textbook makes the 30 and the number crisscross.
Oh, only if what word's in the middle? 30 less than. So here I said 30 decreased by. So it is 30 minus an amount. So decrease 30 by something. So if I decrease 30 by 10, it is 30 minus 10. So be careful. The only one that really turns it around is 30 less than a number. That would be x minus 30. Cool. Now this side to me would be the exceptionally difficult side. And they gotta start to see how this look equal to the product. Now it's gotta tell me 2 pieces after this. The product of. There's gotta be 2 pieces. One is just the number 3, and the other piece is the sum of a number and 6. So I gotta have 3 times the sum of a number and 6. I gotta have that. This is a more difficult problem.
I put it backwards.
Oh yeah, you put the 6 on the outside?
No, I put the 6 in the parentheses before the x. And then
Oh.
the x after the 6.
Gotcha.
Where you plus it.
Yeah. So nowhere does it say like 6 times the number, right? And if I put this instead, if I put this, how would you say this in English? I want you to see the difference. How would you say this in English? The what of what?
The sum of.
The sum of,
3 times the number.
yeah,
plus 6.
3 times the number and 6. So do you see now the main operation would be plus, and then you need of what? Of 2 pieces. This piece and that piece. Whereas over here, what's the main operation? Product. And what are the 2 pieces? This and this. Okay. Again, that, now, to be completely honest, that gets remarkably confusing, right? I do not blame you because we are basically translating. Just like if you wanted to translate from English into Greek, that would probably be difficult if you don't know Greek. So a lot of us just don't really know how math grammar works. And I don't blame you. I don't know how French grammar works. I took 2 years of French in high school. What do I remember? Je vais à la plage. I go to the beach. It's basically. So I don't know how math grammar mixes with English grammar. But I'm hoping that starts to make a little bit of sense. So that works. Now, how do you, and then to solve this shouldn't be the hard part. Go ahead and solve that if you haven't done it already. So what's the very first thing you would do?
3 times x.
Good. So distribute that 3 through.
Plus 18.
Good. 3 times 6, 18. Now there's nothing else I can do on either side, so I can start to do what? Good. Move them across, yeah. So maybe,
Subtract.
yeah, okay, so whichever one you want, and we could subtract the 18, or we can add the x. Okay, the first thing I heard was the plus x. 30 equals
4x.
4x. And then I subtract the 18.
12.
Plus 4.
Good. 12 equals 4x. And you see the last step is almost always divide. So x equals 3. Yes, ma'am.
I don't know why, but I got 6 equals x. I minus x from the beginning.
We have to, yeah, add x. Because you're right, you would get 2x. If you subtracted x, you get 2x here, right? And then divide it by into 12, you get 6. But subtracting x here would not cancel it. So anytime you're doing an equation and you're claiming that something goes away, just make sure that it really does go away. Make sure that what you did actually does cancel it out. Yeah.
Isn't it 3 times x, which is supposed, where did the 4 came from?
Oh, right here.
No.
We have to get, yeah, right there, right?
Yeah, where did
Okay.
the 4 came from?
So right here we have minus x. So how do you kill subtraction of x? You add x, right? So if you add x to both sides, you will get 4x. So we write it up here. Good. So we're right here. Cool? Geo. So I want to get my x's together. So I want to kill these here so that the numbers are left alone. So how do I kill minus x? I add x. So you get 3x and x is 4x's. And then you keep going. Yeah. All right. Okay, so that's the first type of word problem, but I really don't put those into word problems. They're really just one step away from true math. Here's the real word problems. Here we go. So, the problem with word problems in general is you'll notice in algebra a lot of the times it's like, you'll get a problem like Frank puts money into a bank. He forgot how much money he put into each account. Well, right there, right there, I'm like, what the hell's wrong? What? Frank, dude, you get thousands of dollars and you forgot how much you put in your accounts? That's pretty bad, right? You just sell somebody else to handle your money. You're crazy. So you've got to keep in mind that in this class, we are not in the real world yet. We are just getting practice as to how to set things up. In the real world, the problems will have immediate implications. How fast should my rocket go so it will intercept the asteroid so it won't destroy the Earth? Those are equations. Make this equation equal that equation so that they actually end up at the same place at the same time. You with me? That's obviously a real world problem. We'll all die if we don't solve it. Find somebody who knows algebra. Shit. Right? You with me so far? In this class, we're going to get very contrived situations because we're not in the real world. We don't have asteroids coming at us that we know about, right? So, with that in mind, we have something like, well, let's see. Let me make up one of my own. We got Fred and Bob. Fred and Bob's ages. Fred and Bob's ages, I'm not done yet, add up to be 72. Yeah, we do so far. So if you took Fred's age and Bob's age and added them, you would get 72. Now right there, let me just stop. Is there any way you can know how old either one is? I didn't say they're the same age. That's a good point, though. If you divided 72 by 2 and get 36, my next sentence, in order for that to be the right word, my next sentence should be, they are the same age. But I haven't got a next sentence up there yet, so I don't know if they're the same age. Give me one situation that could be true. How old could Fred be? How old then would Bob be?
52 and 20.
Say again?
52 and 20.
I like it. Right? Fred could be 52 and Bob could be 20. Fred could be
50 and not 22.
Fred could be 50 and Bob could be any two that adds up to be 70. Now, obviously, Fred can't be -8, for example. So very often in word problems, you've got to be careful about your answers. If you come up with an answer of x equals to -7, you're saying that Fred is 7 years away from being born. Which is like, you have a psychic, oh wait, 7 years from today, Fred will be born. It was written. No, I mean, we don't have these things. So I have to tell you something else here, don't I? Obviously, I haven't given you enough information to figure them out. So let me tell you that Fred, I can't be that nice. Fred is, I guess actually I have to make it work. Fred is 8 years younger than Bob. Now, here's what makes word problems easier. The first time you read through a word problem, don't worry about the numbers and the math. Right? You'll have to worry about that in a minute. The first thing you're looking for is, what are the parts involved? Who are the players? This might be done here. It's about